So as we move to page 2 here, this is sort of the meat of the lesson, if you will. We're going to start looking at these properties today. And again, the idea today is to look at ones we're familiar with, a linear relation, a quadratic function, so we can extend these properties to some new ideas, polynomials, tomorrow and the next day. So some things we should know about. Domain we know, all real numbers, x values specifically, okay, for any polynomial function. The range, well, the range won't necessarily be all real numbers. For a line, it would be. A line goes up and down forever and ever and ever. But for a quadratic, if you were to think about, I have this lovely picture here, it goes like this. It's going to go down forever and ever and ever, but it only goes up as high as that vertex. So the range of a quadratic really depends on the vertex and which way it opens. Okay, zeros, we just graphed them a second ago, or sorry, we calculated them a second ago. The points where our graph crosses the x-axis, those are kind of important, s and t. We can actually find them for linear ones too, and we're going to give that a try today, find the x-intercepts. The y-intercept, that's an important thing we just looked at for a linear relation. We should also look at it in terms of quadratics and other functions. The nice thing about linear relations is it's easy to find, right? It's the b. For any other function, however, we can also find it pretty quickly because it's the point where x equals 0. So if you make your x value 0, and then you use your equation, you can find the y value that goes with it pretty easily most of the time. Our graphs are going to have mins and maximums. Okay? So we have to look at our picture. Does it have a highest point or a lowest point? If I have a graph that goes like this, it goes up, reaches a maximum, comes back down, and vice versa. Went down like that first, it would have a minimum, right? That's kind of common sense. We did that with periodic functions. Yeah, here's our big new ones, the end behavior. Okay, I want to know what my graph does on the left and the right side. I'm not going to write out the words left and right. What I'm going to do instead is use this notation here in the middle. Okay, as x approaches negative infinity, on the number line, negative infinity, if this was 0, would be way down here at the end, as far as I can possibly think. So that's a way of saying as I go to the left. And then if I go to the right, I go this way, the highest possible number I can think of there would be positive infinity. Again, I'm going to show that by saying as x approaches infinity. And that's my notation to say here's the right-hand side of my graph. I then have to think about my y values. If my y values are going up on a number line on the y values, there's 0. Up would be positive infinity, and down would be negative infinity. And we're going to put these things together. I'll show you an example in a second of how this is going to work. Another big new idea, the leading coefficient. Now, really this is what sign the a value has, whether it's linear, quadratic, whatever it happens to be, it's all about the a value. And what I really care about is the sign. Just like we did a second ago, we did quadratics, and we said a positive opens up. A value tells us what the graph does on the right-hand side. Okay, so a quadratic a second ago that had a positive, well, the right-hand side goes up. Now, because it's quadratic, the left-hand side does the same thing. And there's some tricks and things we're going to learn about that too. And then our degree is the value of the highest exponent. And we talked about that a couple of days ago when we did polynomial functions. Okay, so this is the big key. All these words here, we're going to do some examples. We're going to show you how this works. But this is our big key as we move forward to the next 3 days of learning stuff, okay? So let's take a look at the first example. I want to look at these graphs and figure out some properties of them. Okay, I want to know the domain range. Now, some of these things are things we've done before. These aren't tricks. They aren't new things. Just a little bit of practice is old things. So our domain. This is a quadratic. It's going to go left and right forever and ever and ever. So we'll say it's all real numbers. Our range. It's y. It's made up of lines. So it's all real numbers. However, it doesn't go down and down forever and ever. It only goes down as -1. So it's got to be greater than -1 at all times. And it goes up and up forever and ever. Our zeros I can see. There's one right here, one right here. So I'm going to have 2, 0, and 4, 0. Those are my zeros. Okay, does this function have a minimum or a maximum? Well, it goes down, and then it starts going back up again. So I'd say it has a minimum. Minimum. And if I wanted to, I could say it has a minimum of -1, but it didn't ask us what the minimum value was, just whether it has one or not. Okay, so the new ideas. The end behavior. The end behavior is what happens as I move left and right. Okay, so as I go to the right, and that's how we're going to write this down, x approaches infinity, as I go to the positive side, what's my graph doing as I go to the right? Well, it looks like it's going up. So I'm going to write down that my y values are approaching positive infinity too. So the line I just wrote says, as x goes to the right, y goes up. As x goes to the left, negative infinity, the graph, it goes up still. Okay, there's my end behavior. So right and up, left and up. Okay. E, the sign of the leading coefficient. Well, that's what the right-hand side of the graph does. I can see that it's right here. So because it's approaching positive infinity, I know the leading coefficient must be positive. Okay, and the last piece wants to know the degree, and we recognize this as a quadratic, so our degree is 2. Okay, and that's how we do the first one. Okay, let's take a look at a linear one. Linear one's a little bit different. Same questions, just with a different kind of function. So our domain, it's a line. Lines go left and right forever and ever and ever, and the range go up and down forever and ever and ever. That's never going to change for a line. Hey, do we have zeros? Looks like one. I can see one right here. We're only going to have 1 0 though, right? Because the line can only cross through the x-axis once. Does this have a min or a max? Well, because it goes down and up forever and ever and ever, that doesn't really apply to us. Not applicable. Our end behavior. As I go to the right, my graph is going down. So I'm going to put a negative infinity in there. As I go to the left, my graph is going up. So it's a positive infinity. My leading coefficient. Well, I just said a second ago, as I went to the right, it went down. So my leading coefficient has to be negative. And what is the degree of this? Well, it's a line, a linear thing, so degree is 1. Okay, and that takes us through page 2, okay, with some pictures.